Hello all. In this video, I am going to present the introduction about the parser, the difference between the lexical analysis and the syntactic analysis, representation of grammar, and some error recovery strategy under the parser. First, we are going to see the role of parser. The role of parser. So here, as we know already, what lexical analyzer will do, lexical analyzer is going to scan the input and it is going to produce a token. And the role of parser is it is going to process the token generated by the lexical analyzer and it is going to check whether it has cleared all the syntactic rules. If it has cleared all the syntactic rule, then it is going to produce the parse tree and it is going to group all the token and it is trying to produce the parse tree. And here the parse tree produced by the parser, that is by the syntax analyzer, is going to be the input for the semantic analyzer that going to produce the abstract syntax tree, and that abstract syntax tree, so that parse tree is going to be the input for the intermediate code generation. And here the role of parser diagram has given. Here the source program is going to be the input for the lexical analyzer, and the lexical analyzer is going to produce a token, and parser is going to process the token and it is going to produce the parse tree, and remaining parse tree is going to be the input for the rest of the front end, and a symbol table will be used by all the phase of the compiler. Now syntax analyzer. What is syntax analyzer? Syntax analyzer is going to process the token that produced by the lexical analyzer, and the parser, like another name for syntax analyzer is parser. It is going to process all the token and it is going to grouping the token. It is going to produce the output as a parse tree. While grouping the token, these are all the rules, whether it has cleared all the syntactic rules or all the production rule that will be detected under the syntax analyzer or under the parser. There are two most important tasks is done by the parser. One is parsing the code, and next one is it is going to check whether there is any error is there. If any errors are present, it is going to correct the error, and after correction of error it is going to generate the parse tree. Now we are going to see the difference between the lexical analysis and the syntax analysis. So here the lexical analysis, it is going to process the source program and it is going to produce the token, and syntax analysis is going to process the group of token and it is going to check whether it has followed all the rules under the productions, all the rules of natural languages, all the rules of computer languages, or it has followed the correct data structures. This and all will be checked under the syntax analysis. So lexical analyzer is otherwise called the scanner, and a tokenization it will be done under the lexical analysis. Under the syntax analysis is another name is called the parser. It is going to do the parsing technique and it is going to produce the parse tree as a output. And here in lexical analysis it is going to produce tokens from the lexeme, and in syntax analysis the token is taken as an input and it is going to produce parse tree as the output. Lexical analysis is the first phase of the compiler and the syntax analysis is the second phase of the compiler. And now we are going to check what are all the rules while representing a grammar is required. So here under the grammar there are four main tuples are available: V, T, P, S. These are all the standard tuples under the context-free grammar. So here G is a grammar, V is set of non-terminals, T is set of terminals, P is set of productions, and S is start symbol. And here I have given some definitions of definitions or the rules to be followed under the terminals. So here terminals is nothing but all the lowercase letter, all the operators, all the special symbols like comma, parenthesis, semicolon, and all the digits and all the remaining boldface letters, for example ID, if, this and all will come under the terminals. Non-terminals, all the uppercase letter and some lower italic statement under the grammar will also be considered as an non-terminals. For example, expression, statement, those are all if it is represented under the italic name, then it will be considered as a non-terminal. Start symbol. Under the grammar, many productions are available, n number of productions are available. So under n number of first production, under that first production, the first non-terminal is going to be the start symbol. Production. The rule for production is LHS, arrow and RHS. This is LHS, arrow and the RHS is the rule for the production. So here the production, always the left hand side is going to be the non-terminal and the right hand side is going to be the set of terminals and the non-terminals. And here the example is given for representative grammar. And here this is a grammar consists of 3 productions. And here first we are going to check V. What is V? V is nothing but the set of non-terminals. So non-terminals, totally 3 non-terminals we have used in the given grammar, that is E, T and F. Terminals, the set of terminals are all the symbols and all the lowercase letters. So plus, minus, star, slash, open parenthesis, close parenthesis, and ID is going to be the terminal. S is start symbol. So here this is a head production. Under that E is a non-terminal. So he is here, E is a start symbol. P is a production, all the productions. E plus T, E minus T, T, T star F, T slash F, F, open parenthesis and close parenthesis, E, ID, this and all is production in the given grammar. So now it is a error handling, how the parser is going to handle the error. So first the parser, it is going to check whether any error is there or not. If some errors are there, it is going to report clearly and accurately. After reporting the error, it is going to try to recover the error as soon as possible. And by adding the minimal overhead, it is going to processing the correct program. Next, we are going to see the error recovery strategy. Error recovery strategy, once the error is detected, and it is always trying to recover it. And here the simplest error recovery strategy is quitting the parsing. So quitting the parsing is, one error is detected under the parser, it is not going to process the input string. So that is the easiest and the simplest error recovery strategy. And some of the error recovery strategies are available. One is panic mode recovery. So panic mode recovery is the easiest method of error recovering strategy, which prevents the parser from developing an infinite loop. Second, what it is going to do is, it is going to find whether any error in the statement is available or not. If error is detected in the statement, it is going to leave all the input statement and it is going to stop processing the input. And next what it is going to do is, it is going to find the designated set of synchronizing token. So a designated set of synchronizing token by discarding the input symbol one at a time. So next what it is going to do is, after synchronizing token, it is going to check whether there is any error available because of delimiters like comma, semicolon or closed bracket. This will automatically, this recovery mode will fill that. So advantages, simplicity and never get into the infinite loop. And disadvantages, here it may lead to some additional errors because it is not going to process the set of input symbols. And next error recovery is phrase level recovery. So phrase level recovery, we are going to call it as a local correction, and it is going to process the remaining input when an error is detected. So here in panic mode error recovery, once an error is detected, it is not going to process the remaining input. But in phrase level recovery, even error is detected, it is going to process all the input, and it is going to try to take some corrective measures on the rest of the input statement also. So once the wrong correction we have done, sometime it may lead to the infinite loop. And some samples of local correction are replacing a prefix by some string, and replacing comma by semicolon, deleting extra semicolon and inserting a missing semicolon. Here advantages, it can correct any input string, and disadvantages, it is difficult to cope up with the actual error. And next one is error production. It is also going to check whether there is any error productions of any production with an error in the given grammar or not. This production will detect the anticipated error during the parsing technique. And the next one is global correction, and this is the last error recovery strategy. In global correction, what it is going to do is, it is going to modify the incorrect string into the correct string. For an example, here we are going to take a grammar and we are going to check whether the grammar is accepted by the input string P or not. If it is not, if the string P is not accepted by the given grammar, and here we are going to adopt some algorithm to find the correct parse, to check the parse tree which is going to accept the string Q. So that will be done by the algorithm itself. That algorithm is going to derive the string Q with related to the string P with a smaller number of transformations. These transformations may be the insertions or deletions or the change of tokens. The advantages are phrase level recovery to find the optimal replacement string, and the disadvantages, this strategy is too costly to implement. Here it will lead to time complexity as well as the space complexity. Thank you.